Welcome back to another video on the Maths channel. It's your teacher Mr. Lim here, and in this video we're going to be looking at equivalent and simplified fractions. So by the end of this video, you'll be able to create equivalent fractions and simplify them. But before we do that, I'd like you to have a look at these two recap questions. Find the highest common factor of 42 and 60, and find the lowest common multiple of 21 and 12. Pause the video and have a go. Alright, so for question A, find the highest common factor of 42 and 60. I like to pick one of the numbers which I think will have the least number of factors. So I'm going to pick 42. I think 42 has less. And I'm just going to write down the factors of 42. So there's 1, 42, 2, 21, 3, and 14. 6 and 7. And so from here, I'm going to be looking at 60, and then I'm going to see if I can divide 60 by the highest number. 42, no. Can I divide 60 by the next highest number? 21, no. Can I divide 60 by 14? No. Can I divide 60 by 7? No. Can I divide 60 by 6? Yes. So the highest common factor is 6. Question B, to find the lowest common multiple of 21 and 12. The lowest common multiple, we're going to multiply them and then divide it by the highest common factor. Now, what's the highest common factor of 21 and 12? You should be pretty familiar with this by now, this process. You should be, hopefully you'll be able to get it straight away. The highest common factor is 3. That's the biggest number I can divide both 12 and 21 by. So what is 21 divided by 3? It's 7. 7 times 12 is 84. So that's the lowest common multiple of 21 and 12. 84. Alright, so let's start this lesson. Creating equivalent fractions. Equivalent means equal or equal to. Okay? It sort of has the word equal in it. Okay, so equivalent, equal to. Therefore, equivalent fractions are two or more fractions that are equal to each other. So they might not look the same, but actually they represent the same thing. To create equivalent fractions, we multiply both the numerator and the denominator by the same number. Okay. So we multiply both the top and the bottom by the same number. So let's create 4 equivalent fractions for the following fractions. Half. I'm going to write down, I'm just going to do this one, and then I want you to have a go with B, C, D, and E. So what I could do with half is I could multiply both the top and bottom by 2. If I do that, 1 times 2 is 2, 2 times 2 is 4. I've just created an equivalent fraction. Or I could multiply them by 7. 1 times 7 is 7, 2 times 7 is 14. Or I could multiply them by minus 6. Okay. 1 times minus 6 is minus 6. 2 times minus 6 is minus 12. Or I could multiply them by 11. 1 times 11 is 11. 2 times 11 is 22. Okay, so I've created 4 equivalent fractions. They are all equal to half, even though they look different to each other. They are all equivalent. So, pause the video, have a go with question B, C, D, and E. See if you can create 4 equivalent fractions for each of these. Have a go. Alright, so here are some equivalent fractions that I created. You might have gotten the same ones, you might have gotten different ones. Your different ones doesn't mean it's wrong, because there's actually an infinite amount of different equivalent fractions we could create, as long as they are equal to whatever the fraction is meant to be. So as long as you multiply both the top and bottom by the same number, it's equivalent. Okay? So let's have a look at question B. For 2/3, I multiply both the top and bottom by 2, and by 10, by 5, and by -4. And you might be wondering, why is it that we can just multiply the top and bottom by the same number to create equivalent fractions? Well, let me show you why. If I were to multiply the top by 2, so let's do it like that. If I were to multiply the top by 2 and the bottom by 2, technically 2 divided by 2 is 1. I'm actually timesing it by 1. So I'm actually not changing it at all, because when we times a number by 1, it stays the same. So technically, this 4/6 is still 2/3. It stays the same. Or for this 3/4, if I were to multiply it by -4, and multiply by -4, which is how I got this one, well, -4 divided by -4 is actually +1. I'm actually timesing 3/4 by 1, which is just 3/4. Okay, so that's why I can do it. So here are some examples. For question D, I times it by 2 and -2. I also times it by 10 and -10. Right, so you can use that method. For E, times that by 10, 2, 3, and -4. Alright, I hope you're feeling a little bit more confident in creating equivalent fractions. Can I get you to see if we can answer these questions here? Which of the following fractions is equivalent to 3/7, and what number goes in the box for A, B, and C? Pause the video and have a go. Okay, so here are my answers. Question 2, we've got 18 out of 42. Because if we have a look at this 3/7, what number can we multiply both the top and bottom by to get one of these? So if I multiply it by 3, that's going to give me 9/21. But that says 9/20, so it's not that. If we multiply by 5, we'll get the 15. But 7 times 5 is 35, not 28, so it's not that. If we multiply by 7, we'll get 21 out of 49. So 21 is correct, but 56 is not 49. If we times by 6, 3 times 6 is 18. 7 times 6 is 42, so that's the answer. For question 3, what number goes in the box? Well, here we can see 5 becomes 20 by multiplying by 4. So we need to multiply by 4 as well to that 2. 2 times 4 is 8. Here, 11 times 8 gives us the 88. So we need to times the top by the same number. 8 times 8 is 64. Question C, 5 times 12 will give us a 60. Therefore, we need to times the bottom by 12 as well to give us 108. Alright. Question 4. By writing either equals or not equal to between the fractions, state whether the following pairs of fractions are equivalent or not equivalent. So, if we think about this, how do we go from 1 to 5? We times it by 5. How do we go from 2 to 8? We times it by 4. Well, because they're not the same number, they're not equal to each other. Question B. How do I turn this 8 into 4? We divide it by 2. How do I turn this 4 into 2? We divide it by 2. Well, because we're dividing by the same number, they must be equal to each other. So have a go with question D, E, G, and H. Okay, let's have a look at these. So how do we turn this 9 into 18? We times it by 2. How do we turn this 5 into 15? We times it by 3. Not the same, so not equal to. How do we turn this 15 into 45? Times it by 3. How do we turn this 11 to 33? Times it by 3. Good, so these are equal to each other. How do we turn 36 into 3? Divided by 12. How do we turn 12 into 1? Divided by 12. Equals. Question H. Okay, so this one's different. How can I turn 24 into 28 and 18 into 21? Now we cannot use plus and minus. It always has to be times and divide. So if I were to divide this by 6, it will equal to 4. And then times it by 7, it will give me 28. So if I were to divide this by 6, I'll get 3. If I times that by 7, I'll get 21. So can you see here how they're both exactly the same? So this is equal to each other. Now, personally, I wouldn't do that. I will actually, let me teach you the next part of this lesson, which is simplifying. And then I'll get back to this question to show you what I would do. So the next part of this lesson is simplifying fractions. Now, to simplify fractions, we simply need to find the highest common factor of both the numerator and the denominator and divide, can't spell, and divide them by that number. So let's simplify the following fractions. 12 over 15. What is the highest common factor of 12 and 15? What's the biggest number that we can divide both of them by? By 3. 12 divided by 3 is 4. 15 divided by 3 is 5. I'll do one more with you. 35 and 42. What is the highest common factor of 35 and 42? What's the biggest number I can divide both of them by? 7. 35 divided by 7 is 5. 42 divided by 7 is 6. Have a go with C, D, and E. Alright, so the highest common factor of 20 and 15 is 5. We can divide both of them by 5. 20 divided by 5 is 4. 15 divided by 5 is 3. Question D. The highest common factor of 18 and 27 is 9. 18 divided by 9 is 2. 27 divided by 9 is 3. Question E. The highest common factor of 48 and 30. Now, I think it's 6. So let's divide it by 6. 48 divided by 6 is 8. 30 divided by 6 is 5. Now, let's say, for example, question E, you didn't realize it was 6. So let's just do it over here, 48 over 30. Let's say you can't really think of the number, but you can see that they're both even. So let's divide it by 2. If you were to divide both sides by, well, the top and bottom by 2, we'll get 24 out of 15. Now, you should always ask yourself, can I keep going further? Is there a number that 24 and 15 can both be divided by? And hopefully you realize, yeah, actually, I can divide both of them by 3. If I divide both of them by 3, I'll get 8 over 5, which is the final answer. So, that's how you simplify fractions. Let me go back to this question up here, question H. And that's exactly what I would do. Rather than thinking about what I need to divide and times by, I would simplify the fractions. So, for question H, 18 over 24, what can I divide both of them by? 6. I can divide them both by 6. That gives me 3 over 4. And a 21 over 28. What can I divide both of them by? I can divide both of them by 7. That gives me 3 over 4. Now, because they are both equal to 3 over 4, they must be both equal to each other. Alright, so that's it for this video. I hope you know now how to create equivalent fractions by multiplying both the top and bottom by the same number. Could be negative, could be positive, as long as it's the same number. And how to simplify fractions by dividing both the top and bottom, the numerator and the denominator, by the highest common factor. Okay, the biggest number that they are both divisible by. Alright, so that's it for this video. If you found it helpful, please give it a like and subscribe, and I'll see you in the next video. See you.